Thalamic matrix cells are pivotal for transmodal processing, which involves integrating and distributing sensory and cognitive information across multiple cortical regions to create a unified conscious experience. Here's an in-depth look at their role. 1. Structural connectivity. Diffuse and widespread projections. Unlike core cells, which connect with specific cortical regions, matrix cells project broadly to the superficial cortical layers, layers 3, across multiple cortical areas, enabling cross-modal integration. This architecture allows matrix cells to act as a global communication hub, linking sensory, motor, and associative regions of the brain. 2. Functional contributions. A. Sensory integration. Matrix cells are central to integrating sensory inputs from various modalities, e.g. vision, touch, and sound, into coherent percepts. This integration is essential for experiences like multisensory binding, e.g. combining visual and auditory cues into a single perception of speech. B. Cognitive functions. Attention regulation. Matrix cells contribute to distributing attentional resources by dynamically modulating activity across cortical regions based on relevance and context. Higher order thought. Their connectivity supports executive functions such as planning and decision making by integrating sensory inputs with internal cognitive states. Global cortical synchrony. Matrix cells play a role in synchronizing oscillatory activity across distant cortical areas, a process crucial for maintaining a coherent state of consciousness. These synchronous patterns underpin brain rhythms like alpha and gamma waves, which are associated with focused attention, memory, and conscious awareness. 3. Role in consciousness, maintaining a unified experience. By integrating and distributing sensory and cognitive information across the brain, matrix cells ensure that disparate neural activities contribute to a single, coherent, conscious experience. Disruption and unconsciousness. Under anesthesia, e.g. propofol, matrix cell activity diminishes, breaking down transmodal processing. This results in sensory inputs failing to integrate into a unified perception, leading to loss of consciousness. For implications for disorders, dysfunctions in matrix cells or their connections may underlie disorders involving altered consciousness or cognitive impairments, such as coma or vegetative states, loss of integrative functions. Schizophrenia, distorted integration of sensory and cognitive inputs. Attention deficits, failure to regulate cortical processing dynamically. Summary. Matrix cells enable transmodal processing by connecting and synchronizing diverse cortical regions. Their role in integrating sensory and cognitive information is essential for higher order functions like attention, awareness, and unified perception, making them a cornerstone of conscious experience. Their disruption highlights their centrality to the neurobiological basis of consciousness.